So this was the question up here, converge or diverge. Explain. Any ideas on maybe what the first thing would be that we would need to write down and say, this is important? Yes, you absolutely have to identify that. So we need to say that thing right there is an alternating series. You have to identify it as such, because honestly, if you don't, what comes next won't make a lot of sense, really. So that's an alternating series. Okay. We can see, and by the way, what tells you that it's an alternating series? Yeah, that's right. As n goes from 0 to 1 to 2 to 3, ... That'll just go, plus, minus, plus, minus, plus, minus. Okay, so it's an alternating series. What are the things that are happening that might tell us about convergence or divergence? Yeah, the bottom gets really huge, and?
It's getting close to 0.
What's getting close to 0? Of the nth term, right? Yeah. So let's be careful with the word it still. So if we said limit as n heads towards infinity of just the nth term without any of the alternating stuff on there, that is absolutely heading towards 0. No question about that. And what's the other piece that we have to identify to make this for sure a series that we can make a judgment on? Yeah, terms consistently decrease. Now, this is not something we have to go and analytically prove. Anybody done the derivative of factorial lately? You're going to struggle. Okay? You can. Introduces a whole brand new family of functions. The zeta and the alpha functions and all these different functions you never even heard of. It's pretty crazy. Yeah. So anyways, all you really have to recognize is that if a sub n equals 1 over 2n factorial, then a sub n plus 1, in this case, would just be less than a sub n for 0 to infinity for that interval. So, what we're describing here is an alternating series whose terms consistently decrease in absolute value towards 0. So what's our conclusion? Converges. So we can say, therefore, the original series converges, and it would be the alternating series test that we used to get there, 2n factorial. So I'll just put AST for alternating series test. So the three elements are, you have to identify it as an alternating series. The terms are heading towards 0, consistently decreasing towards 0. Okay. Any questions there on that one? Whoa. Okay. Cool. We're going to keep doing some exploring with alternating series. I think this will be, personally, I think this will be pretty fun. I don't know what the deal is. They just did this new stuff with my computer, and I'm trying to sync things, but not that much. And I'm trying to put it on a diet, but it keeps on, I don't know. It's having a problem. Yeah, it does work. Yes, true. All right. So, guys, we're going to do something kind of new here, but to get us going to something new, we're going to do something a little bit old. And I realize that there's some stuff up above that we need to talk about. We'll go back and talk about that. But I would like for the moment you guys to check out number 1 in this next little mini section. It says for the series, and it gives you the nth term and all that. It says, does the series converge or diverge? So I'd like for you guys to try to answer question A. And then question B, approximate the partial sum S5 by using those first 5 terms, right? Terms 1, 2, 3, 4, 5. And then we'll discuss a little bit about C, okay? So please try. I feel like you can definitely do A and B. C will have to do just a little bit of exploring and see if you all can come up with a good way to handle C. Okay, I want to get you guys going on C here in a second. So let's review A and B. and see how you guys did. So what would be the very first thing you would have to say on A if you were going to prove anything about that? Yep, you got to say it's an alternating series. That'll open the door for everything else that we're about to do here. So is an alternating series. So I like to just tag that on the end. Like that thing right there, it's an alternating series. Then we can do the stuff we need to. What's the next thing that I need to prove as far as convergence, divergence? And are you guys okay with what we're doing here as far as when we do that, all we do is we look at the part that's not alternating, like we ignore the -1 to the whatever, because we're only concerned with the other part when we're talking about this. This would still hold true, I suppose, but we're only concerned about this part. All right, so that does equal 0, right? Numerator's 1, denominator's getting gigantic. We're heading towards 0 for the overall value of the fraction. And as n goes from 1 to 2 to 3 to 4 to 5, is the fraction result consistently decreasing towards that 0? It sure is. So we can say that if a sub n equals 1 over n factorial, a sub n plus 1 is consistently less than a sub n for the interval that we care about, 1 to infinity. Okay, so if all those things are true, it's an alternating series in the terms of decreasing in absolute value towards 0. The series converges. Yep, so you can say, therefore, that series that we were concerned about at the start here does actually converge, and it is the alternating series test that we used to get that, AST. All right, so how are you guys feeling about A? Was A not very similar to the one we just did? I want to give you a little repetition. There. Okay, so S5, I didn't really have to say the last 5 words in that sentence, like S5. It would be the first 5 terms based on what the series is, where it starts. So this would be essentially term 1 plus term 2 plus ... all the way up to term 5. That make sense? So term 1 would just be 1, right? What about term 2? -1/2. Plus term 3 would be 1/6. Plus term 4 would have to be -1/24. Yep. And lastly, the A5 would be 1/120th. Yep. Okay, so that is your S5 right there, and that would be our partial sum. And what did anybody add this up? Negative what? You trailed off there. I didn't hear it. -43 over. Okay. Do you guys get the same thing?
No.
Okay. Or what was an alternative answer here?
19 over 30.
19 over 30.
Mm-hmm.
Anybody? Where do you guys fall on this? I'm assuming.
Oh, I'm wrong.
What did you do wrong?
Oh, I said 1 over 120 for the first one instead of 120 over 120.
Oh, gotcha. The common denominator thing. Okay, gotcha. Okay, so that is our partial sum. Okay. So guys, I'm hoping that number whatever it is, 1, A, and B, even if you made a little arithmetic error or whatever, like Jasmine was mentioning, hopefully this went well for you. Hopefully you were comfortable at least, right?
Yes.
Okay. So let's talk about C. C is very new. C says use the alternating series remainder for S5 to find the maximum error if using S5 to approximate the actual sum. So I want to be really clear about this. This notation right here, that I'm highlighting in red, that is the summation from n equals 1 to infinity. So would you agree with me that if we stop at n equals 5, we've stopped just a tad short? To understate it somewhat, right? We have fallen way short of finding the actual, listen now, this is not something you want to miss, okay? We have fallen way short of finding the actual true sum. I mean, 19/30ths, that sounds great. But if I were you, I would want to know, okay, S5, a little shy of infinity. How far off am I? How bad or good is my estimate? That makes sense? Do you see why someone would want to know this? So let me trace this back to why we're even doing this in the first place. Do you remember? The reason why we're studying series is because in the very near future now, in the next couple of weeks, we're going to start taking functions that are crazy functions, impossible to find an antiderivative of, And we're going to say, you know what? Why don't we just find a power series for that? Much, much easier to find an antiderivative of that. But then on the back end, we're going to say, well, cool, that was really neat and everything that we found a power series for this, but it's only an approximation, and how good or bad was it? We're going to want to answer that question. Was this a really good approximation? Was it really bad? What do we even mean by that, right? How good is good? How bad is too bad? Whatever. We're going to want to try to quantify these things and answer those questions. This is kind of the start to that. So let's see here. Let me draw this out for you real quick. I don't know that I want you to draw this out because I maybe want you to write some different things in here. But I want you guys to do a little thinking here as far as what you think the maximum possible error would be. So 1, we're going to say is, actually it would have to be over here. 1 is there. There's negative 1/2. There is plus 1/6. There is minus 1/24. There is plus 1/120th. So can you see how the graph of this series would go? It jumps back and forth across the x-axis, and what we're doing to get that 19/30th is we just added all those little red dots, right? Okay. So the question is, how bad is 19/30th? Is it really close to the actual sum? Is it way far off? Any ideas on what I could do or what I could think about to answer that question? Yeah, the more terms, certainly, so Jack is right, if you keep going, right? The more terms you add on to the end of that partial sum, like if you did S7 or S10 or S a million, clearly the sum gets more and more accurate to the true sum, right? But what if we just stopped at 5 like we did? How bad is it? Or how good is it? Thoughts? Okay, so you know what? What Brandon just mentioned, I'll write it a little bit differently. I'm going to say that this from n equals 1 to infinity of this whole thing, n plus 1, I think it was 1 over n to the infinity, or 1 factorial, excuse me. Let's just say that that equals s. That's the actual sum, whatever it is. That's the actual sum. So what Brandon just said was, hey, what if we had the actual sum minus S5? What would that actually be? That's the error, right? If you take the actual value and you subtract off your approximation or my approximation, that'll give us the error. I'll put E5 for error based on the fifth term, right? Or the n equals 5. Okay, so Brandon has given us a place to start here. But what we want to do here is we want to figure out how bad is E5? Like how big or small is the error? Let me put it like this. Would you guys agree with me that, I'll put this a different way, could we say that S equals 19/30ths plus E5? The actual sum equals our approximation. Think about how elementary this is. The actual sum is what our approximation is plus however far off we were. And that's all that's really saying. But I think it's important to start to develop this. But the question still remains, how bad, how big is E5? Or how small is it? Is that okay? What would make up, what would we need to build to get E5? What would we need? This goes back to kind of Jack's idea. Right, but how would we get there? What would we need more of?
More terms.
Yeah, we'd need more terms. And so what makes E5? What would be the first part of E5? Not E6.
S6.
Not S6. A6, right? Wouldn't you need the sixth term? So E stands for error, A stands for the term, right? S stands for the partial sum. So think about it like this. Check this out. Guys, you're going somewhere with this. You're going somewhere to really a good place. So would you guys agree with me that E5 equals A6 plus what? A7 plus what? Dot, 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 like forever, essentially. What's going to be true about stay with me now. Come on, I want you to think this through. What's going to be true about A6, A7, A8, A9, A10? I'm not looking for the exact values, but what?
Get smaller.
They're going to get smaller towards 0. We already proved that. And they're going to switch signs every time. Okay? So what could possibly be, knowing that, let's see here. Let's think this through. A5 was positive. So this will be a negative. This will be a positive, et cetera, right? So if that pattern continues, what could be like our biggest error? Like how bad could this be?
E5 is going to be negative.
E5 will, okay, I like that, and I think that that is true. Why would E5 be negative?
Because the biggest number up there is negative.
The biggest, okay, no,
Or that is wrong. The way I said it.
the biggest absolute value
Yes, the biggest absolute value
is comes from a negative number.
Yes.
Agreed. Would you guys, so Josh is starting to get us going somewhere else, so I think it's a good place. Would you guys agree, first of all, that A6 is negative, and that A6 has the biggest absolute value of all the numbers that remain? Okay. A7's positive. A8 would be negative again. But thinking about this as being the biggest remaining absolute value is super important. Come on, keep thinking. What could be the worst this is? We're looking for the maximum error. Johnny? A6 minus A7. Why?
Because that's like the largest difference in absolute value.
Okay. Okay. Let me think this through. Why not? Well, why not add in A8 as well? And A9.
Yeah.
Because it was like when you, it's like if you get A6 minus A7, you're gonna have like a little bracket area where
Okay.
it's gonna be. And
Yes.
the more you add on, the more you're gonna get more exact. But
Yes.
it's a little bracket area.
So the more terms you add on, like A8, A9, A10, isn't that E5 representation just going to get smaller and smaller and smaller? And it wouldn't be E5 anymore. It'd be like E10 or E12 or E20 or whatever it is, right? So the more terms you add in there, the smaller the error gets. Agreed? So if we're looking for the biggest possible error, what should we be looking at? Just A6. Just A6. Think that through. So Johnny really, Josh got us pointed in the right direction with the whole, hey, the biggest remaining absolute value is that negative number there. Johnny's like, well, why don't we just add the next two? Well, wouldn't A6 plus A7 have a smaller absolute value than just A6? Because they're going to cancel each other out to some degree. Just the same way that A6 plus A7 plus A8 would have an even smaller absolute value than the previous two terms. Why not just go with this one right here? Because this, due to the alternating nature, that is going to be the biggest possible error. Anything else added onto that is only going to make the error smaller and smaller and smaller. We want to know how bad this is. So if I told you the maximum error, you could look at it and say, well, hey, that's okay. Or that's too much error. You'd at least know what the biggest possible error would be. So this will hopefully tie into what you see above, but I'll say it down here. I'm going to erase my graph. If you have a converging alternating series, so I'm going to write that out here. This will be part of our answer. So I'm going to say this is a converging. That's important because if it was a diverging, this doesn't apply. So this is a converging alternating series. Therefore, the error is bounded by, so bounded is like the word boundary, right? So the boundary for the error is bounded by the first neglected term. First neglected term. So our partial sum was based on A1 plus ... all the way up to A5. So the first neglected term would be A6. So what I can do now is I can go back up to here. I'm going to erase a little bit. I'm going to say that my error, which I'll formally state as this, absolute value of S minus S5 equals E5. That would be less than or equal to my first neglected term, which I don't have yet, right? what would A6 be?
1 over 720.
1 over 720. And we're looking at the absolute value of it. So I would say that my error from my partial sum above is at most 1 over 720. So is that an acceptable amount of error? I have no idea. We haven't really applied this yet. But for now, we at least know what our error would be bounded by. Later on, if we said, you know what, that's way too much error, what would we do? Do more terms. Throw on another 3 or 4 terms and see what happens. There's more formal ways to do that, but that would be a way you could do it. What do you think? This is your big takeaway. And if you look above, you can kind of see that formally stated. Question, Liz?
So 720 is the absolute value of A6?
1 over 720. 1
Yeah,
720th.
yeah.
Right. Yeah, so if you kept going up here, like if we said, you know, like what's missing here, like what term did we leave off? That would be when n is 6, and 6 factorial is 720. So 1 over 720 was that first term that we left off to form our partial sum. For an alternating series, that's going to define our maximum error. It's going to bound our error.
So is error always positive?
Yeah, we're always going to look at errors being positive. So that's why I went back here and I put those absolute values in there to say, I don't know if S is bigger than S5 right now because it's an alternating series. So I'll just do the absolute value of it and say, all right, it's just going to be 1 over 720.
Okay.
Plus or minus, I don't really care. It's just an error. Okay, other questions? Yeah. Hey, so Emma just asked a good question. Is that the wording that we use? I think so. Some version of that. You got to say this. You have to say that it's a converging alternating series, because if it's a diverging alternating series, the error is not bounded by the first neglected term. Not at all. Not even close. So that doesn't work at all. You need to mention something about the first neglected term, or the first term I left off, or the first term that I didn't write, or I don't know. There's a million different ways you could say that, but the term that didn't get in there, first term that didn't get in there, I don't know. I like first neglected term. And then, yeah, over here we're just going to say, hey, my error is actual sum minus whatever my partial sum was. You don't even really have to have this, the E5 thing. Sometimes I put that in there because sometimes that is included. Just know that that's E5. Sometimes even the letter R is used right there. R5. R stands for remainder, like what is left over after you cut it off, that kind of thing. So yeah, so that's basically it. You guys will get a chance to practice this again right now. So if you guys would, take a look at number 2. Okay, enough Morse code. This will be hopefully one last piece of good repetition from last week to this week. If I'm going to show that this series converges, what are the things I've got to have? Number 1?
It's an alternating.
Yep, I got to say that. This is an alternating series. I've also got to state what else?
Limit as n approaches 0, the
Did you say infinity?
infinity.
Yeah. That is equal to 0. And then we've got to notice that the terms do what? Consistently decrease. So this is how I usually write that. If a sub n equals 1 over root n, then a sub n plus 1 is less than, in this case, a sub n for 1 to infinity. So we're seeing that consistent decreasing pattern. Therefore, the series converges. And since there's just the one series here, if you wanted to say the series, I think I'd be okay with that. Okay, so then B says if the first 4 terms are used to approximate the actual sum, what is the maximum possible error? So again, I think it's an encouragement to you is to realize that this question could be, honestly, this question could be like letter D on FRQ 6, right? Totally out of context. What are you supposed to do? Like, what should you notice first? It's an alternating series, and it's not really alternating, but it's converging. Yeah. So we could say something like this is a converging, as we proved in A, converging alternating series. Therefore, the error is bounded by what?
First neglected term.
Yep, the first neglected term. And if that's the case, all I have to do is find that first neglected term. So it'd be absolute value of s minus s4 is less than or equal to, that first neglected term would be when n is what? 5. So 1 over root 5 would be my maximum possible error for this series. Question, please.
So could you just say that the maximum possible error is like absolute value of A5? Could you say that?
Yeah.
Like,
Yep. I want you to be like flexible and versatile with your notation, like seeing s minus s4 and knowing that that is the exact same thing as A5.
Okay.
Yeah, I would definitely want you to know that. So I'd be okay. As long as you tell me, hey, it's converging alternating series, so I'm going to be hunting down this first neglected term. If you just say, hey, A5 is this, or my error s minus s4 is this, I'm okay with that too. Yeah, go ahead, Emma. Yes. We live in a totally different world than Algebra 1 students. Yeah, I know. It's a little uncomfortable. If you want to write root 5 over 5, I'm fine with that.
So do we have to write the little equation right there with s minus s4 is less than or equal to 1 over root 5, or can you say the first neglected?
So like the way this is worded, I think you could just say, therefore, the max error is 1 over root 5. But again, I want you to be comfortable and fluent with the notation. I'd want you to look at s minus s4 and be like, that's the error. Versus, oh my gosh, I don't know what that means. You'd want to know what that meant. Other questions on that one? Okay, so I want to do just a little bit more here, and then we'll transition. I hope you remember this. Maybe you remember how the narrative of our series is we have all these little series, and we're cheering for them to converge, and we have these negative, kind of tough coaches like the nth term test who never tell you anything nice. We have the balanced coaches, like the integral test or the p-test, comparison tests and all that stuff, right? And then do you remember how the alternating series test was kind of like the soccer mom? Like if you're the worst person on the team, like you're a terrible, terrible player, she's still going to give you a juice box and an apple and pat you on the back and say, we're proud of you. She's not going to tell you that you're terrible. She's just going to, she'll be nice. But if you're doing well, she'll tell you that, right? She's like, you're going to converge. Good job, right? So, attaboy, there we go. So, would it be fair to say then that if a series is an alternating series, it's got a great chance to converge, right? The bar is pretty darn low for soccer mom, right? Basically, if you get out there and you have a pulse, she's going to give you the snack at the end, right? You didn't converge, you diverged. I'm sorry. Yeah, I don't know what soccer mom's going to do about that unless she's a doctor or something. Anyways, so again, wouldn't it be fair to say that the whole plus minus thing is extremely helpful for convergence? So this next series of thoughts is going to be along these lines. We're going to call these tests kind of the skeptics. Skeptics, you know what I'm talking about? It'd be like this. Listen, there's a good analogy to be had here. It'd be like this. Let's say you're on a basketball team and you had a good game, scored like 18 points and had 9 rebounds and 5 assists, and it was a good game. Great. You come back to the bench, and maybe it's one of those assistant coaches, and you come back and you're pretty pumped. You're like, yes, I'm having such a good game. And the assistant coach leans over and they're like, yeah, did you realize that they have their worst player guarding you? Did you realize that? Did you realize that the person guarding you this whole game can barely put one foot in front of the other? And yeah, you scored 18 and all those other stats. That's neat and everything. But let's be honest. They're guarding you with someone that's well below your caliber, right? But what's the next? Isn't the next phrase? Hey, listen. What if the other team had their 6'6", 205-pound stud defensive player guarding you, like Nick? You pointed at yourself, so. What would happen then? what happens if they take, what happens if they make some halftime adjustments or adjustments for the next game and they take off that poor soul trying to guard you and they put on their best defensive player? Can you still score 18?
Yes.
So, you know what? The answer to that question is going to determine your convergence or divergence. If the answer is, you know what? In the end, like if you can prove it, it doesn't really matter who they put on me. I'm going to be scoring over them, under them, through them, dunking on them, hitting threes. I don't care if it's their awesome defensive player or their weakest defensive player. I will score. Or if the answer is like, yeah, you know what? I really hope they don't put that guy on me because if they do, I'm probably going to have like 11 turnovers in the second half and no points, right? So your answer, your proof of your answer to that question will go a long ways towards determining whether you converge or not. So we're talking about absolute and conditional convergence. So I want you to think about those words. Absolute convergence. You know what that means? And I'll personify this. This basically means this. I'll converge whether you give me the plus or minus or not. It don't matter. You're a little cocky, right? You give me the plus or minus or not, I don't really care. I'm still going to converge, right? Conditional convergence means this. Please, 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 let me have my plus minus. Because if I don't get my plus minus, I'm not going to converge. That makes sense? Conditional means I'm going to converge on the condition of me keeping my plus minus. But if you take away my plus minus, I'm not going to converge anymore. That's pretty weak. I agree. And we might have to mock them a little bit, but whatever. Okay. So, armed with that narrative, I want you to think about this. The absolute convergence test. If I'm going to say it my own way, but see if what's written up there also makes sense. If I take away the plus minus, does that make sense? Yes. With the absolute values there? If I take away the plus minus and I still get convergence, doesn't that mean that if the plus minus is allowed to be in there, we're going to converge? So if I can score 18 points on their best defensive player, and then later on they put their worst defensive player on me, don't you think I'm going to score at least 18 points again? Does that make sense? The converse of this statement is not necessarily true. Okay, so another way to think about this would be this. I like this second set of statements. The series is absolutely convergent if you take away the plus minus and you still get convergence. However, the series you're looking at is conditionally convergent if with the plus minus you get convergence, but then if you take it away you get divergence, right? It needs it. The one condition for convergence would be I need my plus minus. Don't take them away. Question?
So this is basically taking away the alternating series and just going back to like the p-test and integral test.
That's right. And so if you take it away and you use some other test like that, what happens? That'll help us understand, do I really need the plus minus? Yes or no? If I don't need them, I'm absolutely convergent. If I do need them, I'm conditionally convergent, right? I converge only if I get my plus minus.
So it would be like you just ignore the alternating.
Well, we're going to put them in absolute values, which basically allows us to ignore them.
Because then it would just be one.
Exactly. Yep. Okay, so let's do just one of these, and we'll string this along towards next time as well. So let's try this first one, I think. Yes. Okay. This number one here is a classic. For sure. So think about, I want you to think about this. This, without what we're about to do here, this is a really funky one. Because sine of n, you all know that sine has some positive outputs, and it's got some negative outputs. But we are not plugging in pi over 4, pi over 2, 3 pi over 4. We're not plugging in these nice unit circle numbers. We're plugging in what? 1, 2, 3, 4, 5. And so are the signs going to go plus, minus, plus, minus? Highly unlikely, right? It's probably going to go like plus, plus, minus, 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 plus, minus, minus, plus, plus, plus. There's going to be just a bunch of pluses and minuses. This is a classic scenario where absolute / conditional convergence could really help us. So check this out. I look at this and I can see that some of the terms are going to have some positives and negatives. They're going to go all over the place. So what I do is this. This series right here, if if I absolute value it, what does that do? Let's think this over. The numerator. Tell me about the numerator. It's what? It does not get bigger. Well, sometimes it does, but sometimes it doesn't. What does the numerator do? Sure. And but if you stretch that circle out onto an xy axis, what does the graph of sine of n look like? Doesn't it just oscillates forever? The point is, though, what's the biggest possible output? 1. What's the smallest?
0.
No. -1. Well, I'm just talking about sine of n. I'm only talking about sine of n. So wouldn't it be fair to say that this is going to oscillate somewhere between -1 and 1? And then the connection I think that Brandon just made is certainly true. If we're going to absolute value that, don't we get somewhere between 0 and 1? Okay. So if the numerator is somewhere between 0 and 1, and the denominator is n squared, what kind of a test could I use for this? Well, no, the absolute values take it away. Take away the alternating piece. What could I use? The numerator is going to be somewhere between 0 and 1. The p-test, right? So we could say this is essentially a p-series. There we go. And p equals 2. What's so important about p being 2? Because it's bigger than 1, therefore that. Yep. Therefore, this series, and I'm going to use my notation really carefully here, this series converges. So in other words, if I took away all the pluses and minuses that be in there somewhere, I don't know exactly where they're all going to be, but we don't really care at this point. We don't need to know. So if we take away all the pluses and minuses, I still get convergence. This is that really cocky player that's like, you know what? I don't care who you put on me. Double team me. Triple team me. I'm still going to get my 18 points and 12 rebounds, right? Okay. So what we can do now is we can say, therefore, the original series, which had the benefit of going up against the weakest defender on the team, a.k.a. it's got a bunch of pluses and minuses in there. So if you take away the pluses and minuses and you still get convergence, if you allow it to have all the pluses and minuses, what will happen? It's going to definitely converge, right? Even, I guess you could say, even a stronger case for convergence, right? That also would have to converge. Okay? Now.
So is sine of n over n squared not a
Well, if you leave that in there, so the hard part is it's technically not alternating, right? So I like having, with the absolute values in there, you can basically say the numerator is going to be some constant between 0 and 1, right? And so, yes, if you took away the absolute values, it would be like an alternating p-series. Yeah. And so that's why I want to get rid of all that pluses and minuses stuff and just say, all right, what would happen if we took those away? And that'll allow us to make a conclusion about the previous. So let me tag this on. I don't know. I forgot to write this. We definitely could say this. We could say that this converges absolutely. I don't think that we need to say like the absolute convergence test. We could just say converges absolutely, or in other cases, maybe we say converges conditionally. Not really factoring out sine of n. What I'm looking at the terms. The terms are going to be some constant, right? Some number between 0 and 1. It's not a different function necessarily, right? Here's what's unique about this. We know the output for sine. No, think about this. Don't we know that the output for sine is between 0 and 1? Right? And what defines a p-test is this. Right? 1 over sigma 1 over n to the p. So if the numerator is somewhere between 0 and 1, well, it could be some constant, sure. So like if this was a 9, let's get it out of there, and now it's a 1, right? The issue is, like, if that was something other than some trig function between 0 and 1, if it like increased constantly, you know, maybe it was like e to the n or something, now that's out. You know, yeah, that's the problem, right? It's just going to oscillate between 0 and 1. So all we have to really look at is, like, what's the degree of the denominator? And we're good. Okay. Good question. I don't think so, because of the whole 0 to 1 thing. Yeah. Now you could do it other ways. Like if you look at that, so here's the thing. What is so beautiful about these is there's more than one way to do this. I think you could probably use, no, you couldn't use limit comparison. That would be weird. You could just use straight up comparison, like direct comparison. Couldn't use integral. You maybe could use integral with, no, you couldn't use it with parts, I don't think. Couldn't use, I think you'd have to either use comparison or p. You'd have to do some work, and that's why I wanted to avoid comparison, because they usually take some real work. It's hard because you're like, what does this compare to? I don't know. You start messing around with your graph, and you're like, well, that didn't work, but that almost does, and that kind of does. Half hour later, you may or may not have gotten anything good. Maybe you did. Maybe it wasn't that bad. Exactly. Yeah. Emma, go ahead. Yes. What spurred me to think about that is just like looking at it from the perspective of like, what do I have here? Like, what does sine of n do, and is that important? Like, if sine of n increased, I'd have to ask myself, well, gosh, does sine of n eventually increase faster than n squared or less than n squared? I would think of that rankings thing. And then that's why I did the thing in CERN. Like, what does sine of n even do? It does this. So knowledge of graphs, I think, would be super helpful here. Like, if I had absolutely no clue what sine of n looked like on a graph, and I didn't have a calculator to help me with that, I'd be in real trouble, right? So I can see why you'd say, well, I don't know if I could have come up with that on my own. My next question would be, well, do you know what the graph looks like? And if you do, then I would say you actually have more of a chance than you think you do. But if you're like, man, I got no idea what sine of n looks like, I would agree and say, I don't know where you would start, because I think the graph would be really helpful. Yeah, I think that's always a challenge with math teachers, get students to realize you got this function. The function will be represented with a table, with a graph, and they all, like, the meanings are all connected. And so it's important to be able to make those connections. Yeah. Quickly, yeah. Yeah. No, because tangent's range is negative infinity to infinity. And so then you get this infinity over n squared, but then n is heading towards infinity. Which one grows faster? That's going to be a struggle. That'd be a struggle for sure. Josh, can you pack it up real quick? I want to get these kids.
Oh, yes.
Thank you.
All harmonics.
Sorry? Unless it's an alternating harmonic.